All right, well, welcome to another PSL demo day. I'm Jason DeBacker, president of the PSL Foundation and an associate professor of economics at the University of South Carolina. Today, I'm going to present on how to analyze stacked reforms using tax calculator and a little bit of tax brain. I advertise this as using tax brain, but it turns out it's a little bit easier in tax calculator right now, although I'll mention functionality we'll be adding to tax brain to do this. Let me start and I'll share my screen. All right, and I'm going to walk through a notebook here, a Google Colab notebook. So let me share that in the comments if people want to follow along. And essentially what I'm going to do, so kind of traditionally, if we look at how revenue estimating is done, so estimating the revenue effects of tax proposals, what's done, and here's a view of this from the Joint Committee on Taxation, what's done is that it's done provision by provision. And so you can see this is their analysis of the recent American Rescue Plan, and you can see kind of each provision in this package of provisions has its own line and a corresponding revenue estimate. And then we can get down to the total for the bill that's going to sum up all of these different provisions. And important here is that these provisions interact, right? If we change, say, tax rates, that's going to affect the value of a deduction. And so we need to account for these interactions. And so what that means is that when you do this stacking, the order matters, all right? And so what we want to do, or what I'll do today, is kind of demonstrate how to produce a stacked revenue estimate, so a line by line estimate, kind of like what JCT has here, with PSL models, okay? And in particular, I'm going to highlight using tax calculator because the interface is really easy, and in about 8 lines of code, we can generate a stacked reform like this JCT estimate, okay? All right, so let me jump back to the notebook I just shared the link for. So we're going to walk through this notebook here, and kind of first thing to do is we're just going to, in our Colab notebook, install these PSL packages we'll use from Conda Forge. Both tax brain and tax calculator are on Conda Forge, and we're going to install from that location. And then after that, we're going to just import those packages as well as a couple other Python packages that'll prove useful in like manipulating and formatting our output. And those are NumPy and Pandas. All right, so just for something concrete to work with, what I'm going to use is a reform that represents the campaign proposals of President Biden. Okay, so this is a set of changes in tax law that are fairly expansive, and so this is a nice example to use where we'll kind of go through provision by provision here and estimate the revenue impact of each of these provisions. I'm getting this reform from the PSL organization repository called Examples, and in this Examples repository, it contains kind of examples to work with different PSL models. So if I go to the tax calc folder, I can see a number of different reform files that are represented by these JSON files. And the one I'm going to work with is this one titled Biden 2020 JSON. Okay. What I've done kind of in the dark here is I've clicked 2 cells to run. This one that is just creating an instance of our tax brain object. We're calling it TB static. As arguments there, we're passing kind of the start and end year we set before. We're telling it to use the CPS data file. This is something that's available to everybody. And then we're passing the URL to that reform from the PSL examples repository. So that reform, remember, was looking at the Biden 2020 campaign proposals. We've run TaxBrain. That TaxBrain object has a method called run. And what that does is that computes over the budget window we're looking at the kind of changes in individual tax liability for all of those individuals represented in those CPS microdata. And then following that, just use the TaxBrain weighted totals method to just get the combined total, payroll plus individual income tax totals for both the baseline, current law baseline, and then the reform, which represents how Biden's changes to current law would affect revenue. And then we've got a difference for those representing our changes in revenue from the Biden proposals altogether. So you can see ranging between $98 and $185 billion per year over this budget window. Right, so that's kind of the total revenue estimate. Very easy to do with tax brain, but
can I ask you, Jason, a question? So that weighted totals function, when you put in combined, that tells you the type of revenue you want to see that's affected, and it's just automatically going to print that data frame of base, reform, and difference.
Right, that's right. Yeah, so the tax brain method weighted totals is going to return a data frame. And it's going to, the argument here we're passing is combined is individual income tax plus payroll tax, or you could pass it just an argument for individual income tax or just payroll tax if you wished. Yep. Yeah, the object return is a data frame, which is just shown here below the cell. Right, but in many cases we want to, kind of analyze different provisions individually. You might think about as a policymaker or somebody thinking about policy, you want to, well, what if we take out this provision and put in another? What is this one provision we're pulling out doing? Okay, so what I'm going to do next is create a stacked revenue estimate so we can look at each of these provisions on their own. Okay. All right, so the kind of first step to that is just decomposing that overall set of changes, right? So if I look back at the Biden JSON, right, there were a bunch of different parameters that were changed here, okay? And what I want to do is I want to take each of these and split them into parts, right? And so there's many ways you could think about doing this. We could do it, line by line above. So what's the effect of just changing bracket 5 and 6 or whatever? I'm going to kind of group them together in ways that I think have some semblance of togetherness here. We've got, for instance, what I'm going to do is I'm going to take all the rate and bracket changes for the individual income tax and group them together as one provision here. So I'm going to take those components of the JSON and put of the overall file representing all the reforms. I'm going to put them in a JSON string representing, what are those reforms, or excuse me, those provisions just affecting brackets and rates. All right. So I'm going to put that in a JSON. I'm going to separately do the qualified business income deduction as its own provision. Okay. So I take the changes of parameters affecting QBID and put those in a JSON string. I'll take the payroll tax changes, put them in their own JSON string, and likewise for some other provisions here. So we've got changes to capital gains rates, we've got deduction limitations, changes to EITC eligibility, changes to tax advantage retirement accounts. And so I'm putting each of these different kind of provisions in groups, and each of those groups of provisions are in these different JSONs. You could have an even finer decomposition if you wanted. I'm illustrating here just the general method you'll go about doing this, which is take all of the total provisions and break them up into their own JSON strings. Okay. So that's what's done in that cell. Right. Next, what I'm going to do is I'm going to put each of these JSON strings into a dictionary. All right. So I broke up all of the Biden proposal into 7 different groupings. Okay. So I'm going to put those 7 strings into this dictionary. And I'm also going to put at the front of this dictionary, the first element is going to be just the current law baseline, to which I'll pass just an empty dictionary. Right? It'll be helpful to have that in here to compute changes from the current law baseline. And what I'm doing here, besides passing those or putting those strings into the dictionary, I'm creating keys that go with those JSON strings that are somewhat descriptive, because these are going to help me describe my output. They'll eventually become labels in my table, identifying what each of these provisions represents. So I'm just going to put these things in a dictionary. And then now here's where the fun begins. So far, we've just taken our overall proposal, broken it into provisions, put those provisions in the dictionary so we can iterate over that object. Now here, we're going to interact with tax calculator. All right. And so what we're going to do is we're going to create an instance of the tax calculator policy and records classes. All right, that's what's done up here. And I'm going to initialize an empty dictionary that's going to contain my results. In this case, what I care about is the revenue from these different reforms. I'm going to call this dictionary revenue output. And then after that, we've got 6 or 7 lines of code here where we're just going to iterate over our dictionary of provisions and apply those provisions to our objects that go into tax calculator. So specifically, we're going to update our policy object with those additional provisions that we've done for this reform. Then we're going to update the calculator object with that new policy object. And then after that, once we've got our calculator specified with the new tax law, we're going to loop over the years here of the budget window, right? So we're going to update our calculator with the new policy, and then we're going to compute, right, for each year in our budget window, what the changes to tax liability for every individual in those microdata are. Here, what I'm going to show you is how we do revenue estimates. So what I'm going to take from this is I'm just going to compute the aggregate revenue from these different provisions in every budget year, okay? And I've just got it printing out what provision we're looking at so we can kind of see as this goes what we're working on, okay?
Right, I have a question for you, Jason.
Yeah,
It seems like there's some implicit cumulative property in tax calculator that when you put a new revenue on, you put a new reform in from the JSON, it's comparing it to the most recent reform added to the next most recent reform and on and on.
Yeah, that's a good observation. And this is a really nice property of how tax calculator works. The policy object is representing the tax code through some parameters. And when we initialize a policy object, passing it nothing, it's just going to create a set of policy parameters that represent the current law baseline. When we update the policy object with this implement reform method, what we're doing is we're changing those parameters from current law to whatever we've specified, where we only have to specify our changes from current law. So the nice thing is we don't have to specify what every tax law parameter is to analyze the Biden proposals. We only have to look at what are the changes from the current law that get us to tax law under Biden's proposals. And so that's exactly right. This policy object is kind of incremental. And so with each of these reforms, as we loop over that dictionary, we're going from current law baseline to, in this case, what we did first was repeal those TCJA rate cuts. Then we're going to repeal QBID. Then we're going to, on top of that, apply the payroll taxes on earnings above incomes of 400,000 and so on. And so each of those is added incrementally to this policy object. And in the end, once we've added all those reforms, we get to the kind of what tax law would be under Biden's campaign proposals. And so we're really making use of that way in which the policy object represents tax law and updates tax law based on changes in parameters as we iterate over this dictionary. And so that was key in kind of how we specified that dictionary of the different provisions, because each of those provisions, each of those JSON strings weren't cumulative. They just represented some particular changes to parameters. And so the way this becomes cumulative and we get the full effect of the reform is because of the way in which this policy object handles tax law and changes in tax law. So I think that's a nice property here, and it makes it really easy to kind of iterate over these. Our JSON strings were very simple. They just represented each of these provisions. We didn't have to write cumulative JSONs that kept adding more and more provisions. And that's nice because we could go back and like change the order here of the dictionary we specified very easily without having to rewrite these JSONs. We could just move around the key value pairs and move up, changes to retirement plans and down changes to payroll taxes if we wished. And we'd be able to see then kind of a revenue estimates with a different stacking order. Right, so while we've been talking, the tax calculator has been churning away. We've run it 70 times here, one for each of the budget year windows, 10 times, one for each of the different provisions, which we had, or groups of provisions, which we had 7 of here. So we've run tax calculator 70 times. We've computed the revenue changes. And what we've got here is we've got a dictionary of revenue output where I put in, or in that dictionary are keys that are the same keys we defined are some NumPy arrays, which are populated now with the revenue for each year in the budget window. Okay. All right,
Can I ask you another quick question, Jason?
Right.
Looks like that took 2 minutes and 39 seconds to run in Google Colab. It would go quite a bit faster if you were just running that on your local machine. Is that
depending on your machine? Yeah, but yeah, for most of us, I think they'll go much faster. That's right.
70 times in 2 minutes 39 seconds on the slow end feels fast to me.
Yeah, no, it's got great performance. That's right. And we're gonna, now what we'll do is, we want to look at this output in an easy to kind of understand way, kind of create a table like JCT had that we viewed at the beginning. And so what we're gonna do now is just a set of formatting. So we're gonna take our dictionary, put it in a data frame. We're gonna, what we care about are differences, not just the aggregate revenue from each, under each provision. We're gonna look at differences from one of these iterations to the next. So we'll get kind of differences in from the first set of first set of provisions relative to the baseline. And then the next line will show us, the difference of repealing qubit after you've already made these rate changes and so on. All right, and then, so we're gonna compute some differences. We'll just drop the current law baseline because changes from that are 0, or between the current law baseline and itself are 0. And then we'll compute some totals over the 2021 to 2030 budget window. And then we'll create a row of totals over all years, or over all provisions for each year. And then we'll just display that. So we can run that cell. And what we get is a table like this, where we've got each of the 7 provisions we specified, and then a total across all of those provisions, again, for each of the budget years, and then a total for the budget window, right? And what you'd want to do when you do this, just to make sure you didn't make an error, because one place error can enter into this is when you create those individual JSONs of the different provisions or groups of provisions, you might miss 1 or 2. And so it kind of a nice check here is go back and look at this total row, right? Do those numbers match what we got when we analyzed our JSON that included all of the reforms together, right? So that's a check that you didn't miss anything. Right here, they check out, but that'll be something, as you do this on your own for your own analysis, I would recommend always going back and make sure your total, once you've done this stack reform, is the same as the total you get when you've lumped everything together. Okay, just to make sure you don't miss anything, because that is a margin where error can enter in here.
So because we're looking at changes, if there were a baseline row, that would just be zeros across the top row, right?
Correct. Yep. That's right. Yeah. So we could. Yeah. So kind of what I did here was I dropped that baseline row, but if we've got that baseline, there's just no change there from itself. Yep. And so that's really it. So kind of the key, I've shared this notebook, so hopefully you can replicate this on your own as you are interested in doing this type of analysis, looking provision by provision. And again, kind of the keys are setting up those different JSON strings to represent each provision or groups of provisions that you want to analyze separately. And once you have that, this code for doing the loop over the same, and then just a little bit of formatting for your output, so you can kind of get what you want to look at, which is changes by provision by year. And so this is again a nice way to do this with Tax Calculator. With TaxBrain, you can do this. It's a little bit more cumbersome for a few reasons, but what we're going to do here, I think myself working with the maintainer of TaxBrain, Anderson Fraley, will kind of put this stack reform as like an option in that run method. So you can just pass a dictionary, just like we created here, to TaxBrain, and it'll return a stack reform like we're looking at here, and kind of do that loop and formatting of the output for you behind the scenes. But right now that's not quite built in. And so I think this is a nice example to work from. Also, if you're interested in not just revenue, but other distributional analysis, you could, instead of saving the revenue along the way as we're doing here, you could just save the data frame of the microdata, or distributional tables, or so on, and so that you could look at other aspects of this set of provisions in a way where you can kind of carve out each provision's effect on whatever you're interested in looking at, be it revenue or distributional impacts. All right, so with that, let me offer up for any questions you might have in this talk.
I have a question, something that kind of sticks out to me that I've never dug deep into, but the idea that these policies interact with each other and the order in which you run those might matter as to how big the revenue effect of that policy is. So if there were some, I guess what I'm saying is that if there were some kind of headline provision and it's estimated to be X billion dollars in this year or that year or over the budget window, that would be a really nice sensitivity analysis to do, is do a few different permutations of the order in which the provisions are stacked in this type of thing and see how much the revenue estimate for that provision changes. Because if I were kind of an evil policy analyst, I could cherry pick the order that gives me the most or the least revenue depending on what I want. And so that sensitivity analysis seems like it'd be a valuable tool for people to use.
Yeah. So that's a good point. So, I mean, overall, we're going to have the same revenue effects of the reform as a whole, but as you change the order of these provisions, you can change the magnitude of any given provision. For example, in this case, we did the repeal of the TCJA rate cuts before the repeal of the qualified business income deduction. Now that deduction is worth even more at higher rates. So kind of doing the rate cuts first makes the effect of repealing this qualified business income deduction look larger than it would be if we did repeal of QBID before the rate cuts. And so that order does matter. Kind of traditionally in revenue estimating, places like JCT and Treasury have a kind of a norms with respect to the order with which you analyze these things. So typically things like rate cuts come first, changes to deductions come later. But you're right, as any individual does this, they can certainly change the order and kind of make things look more or less impactful with that order, although they can't change the total size of all of the provisions together. Right, good suggestion or comment. All right, well, thank you so much for viewing. I'll follow this up with a blog post where I'll again provide a link to this notebook so you can use it as an example, and I'll provide there a little bit more instruction about how this was done and what to look for in the future from TaxBrain and these capabilities. All right, so thanks so much.